Okay, so today we're going to be learning about geometric sequences. And so we've looked at sequences before. Geometric sequences are a little bit different. So hopefully this isn't too terribly mind-blowing for you. So again, understanding geometric sequences. And our essential question is, how are terms in a geometric sequence related? So a geometric sequence by definition is a sequence where the ratio of successive terms is constant. So basically, all that means is that whatever we're just multiplying the previous term by a constant, which is what we'll find out is called the common ratio. So just for an example of a geometric sequence, if I have the number 1 and I decide to multiply all terms in the sequence by 2, then 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And then the pattern would just continue, so on and so forth. So as you can see, each time I'm dividing or multiplying, each term by 2 to get to the next term. So it's not adding. It's not like a sequence like what we had before. This is multiplying. So the common ratio of a geometric sequence is how much it's increasing or how much you're multiplying by each time. So in this case, R would be 2 because I multiplied by 2 each time. So we have a formula. Remember when we were doing recursive and explicit rules before, way back. We had that for we had a specific rules. Well, for geometric sequences, we also have a specific rule. So for all n bigger than or equal to 2, the nth term f of n of a geometric sequence of a common ratio is f of n, where you just write f of n minus 1 times the common ratio. So when I go to solve these problems, I'm just going to try to identify what the common ratio is, figure out what f of n is, and calculate f of 5, f of 6, and f of 7. So for this one right here, I have the sequences going 6, 12, 24, and 48. So what I'm seeing, and hopefully what you're seeing too, is that this is increasing by 2 each time, right? 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So in this case, my common ratio is going to be just 2. So then my sequence is going to be f of n is equal to f of n minus 1 times the common ratio, 2. So it's that simple, f of n minus 1 times 2. So to figure out f of 5, this is where I do a little bit of math. I'm just going to plug 5 in for n and solve. So f of 5 is going to be really f of 4, right? So hold on, f of 4. So I'm really looking at f of 4 times 2. Well, f of 4 is 1, 2, 3, 4 is 48. So this is where because it's a recursive routine, this is where I have to kind of go back and look at and see what f of 4 is. And f of 4 was 48. So I'm really looking at 48 times 2. And 48 times 2 is 96. Okay. F of 5 is going to be 96. F of 6, I'm going to do the same thing. I'm going to have f of 6, which is, and I'll write this one out, f of 6 minus 1, which is equal to f of 5, and then times 2. And then f of 5 times 2 is 96, so 96 times 2 is equal to 96 times 2, quick math, 192. And then I got to calculate f of 7, so I'm hoping that we have enough of a pattern where you don't really need to see me calculate it, but understand that I'm just really doing, to calculate f of 7, I'm going to do f of 6 times 2. And f of 6 times 2 is equal to 192 times 2. And then 192 times 2 is 384. Okay, so that's how we calculate the next terms in the geometric sequence. Let's do another example to kind of make sure we understand what's going on. So in this one, I'm going 100, 50, 25, 12.5, and the pattern's continuing. Well, I'm dividing by 2, but remember, this is a ratio is a fraction, or not a fraction, but you're multiplying something by. So multiplying is not the same as dividing, but when I multiply by fractions, it is the same as dividing. So really, I'm multiplying by a half each time, right? It's being halved. 100 times 1/2 is 50, or 100 divided by 2 is 50. So in this case, my common ratio is going to be 1/2. And then so when I write my recursive sequence, using the common ratio, I'm going to have f of n minus 1 times 1/2. And that's going to give me my sequence. So then again, calculating f of 5, I'm going to have f of 5 minus 1 times 1/2. F times 5, f of 5 minus 1 is f of 4. 4 times 1/2, which is equal to, we have 12.5 times 1/2, which is equal to, I'm going to move this so you can actually see what I'm doing. I can see what I'm doing. All right, and then 12.5 times 1/2 is 6.25. So then the rest of these terms, f of 6 is really just 1/2 times 6.25 is 3.125. And then f of 7 is 3.125 times half, which is 1.5625. You see, this is just getting increasingly smaller as it goes on, right? We would actually expect it to end at 0 because we can't go below 0, right? And it's not going to end up with a negative magically. All right, so then example 2 is where we're kind of like applying it to real life. So a bungee jumper jumps from a bridge. The table shows the bungee jumper's height above the ground at the top of each bounce. The height forms a geometric sequence. What is the bungee jumper's height at the top of the 5th bounce? So we're going to have to, again, figure out what the ratio is. And then go from there. So if I look, I'm going from 200 to 80 to 32. So that's not, it's obviously decreasing, which means I'm multiplying by some sort of fraction, but it's not decreasing at like a constant rate. So I got to figure out, not a constant rate, but it's not like something nice like 1/2. So I got to figure out what is it decreasing by each time. So remember, this basically means, like if I were to do some quick math, to get from 200 to 80, then 200 times x has to equal 80, right? So this is just some quick math. So the reason why I said 200 times x is because really that's what the recursive sequence, like what the geometric sequence is that the previous term times the number equals the next term. So previous term is 200 times the number equals 80. And actually, I'll use r so that way we're actually talking about the common ratio. So to solve for this, I'm going to divide by 200. And when I divide by 200, I get r is equal to 80 over 200, which is a fraction that can be reduced. I can divide them both actually by a number. I can divide them both by 40. So 8 divided by 40, 80 divided by 40 is 2. 200 divided by 40 is 5. So now I have my common ratio is 2/5. So then I'm going to go ahead and write my sequence. My sequence is f of n is equal to 2/5 times f of n minus 1. And I know I switched the order, but I prefer personally to have the common ratio out in front instead of afterwards. It just looks better to me. It doesn't really matter though because it's commutative. It goes both ways. So now I can calculate the next terms. Well, to find f of 5, I need to find f of 4. So let's go ahead and find f of 4. So f of 4 is going to equal 2/5 times f of 3, which is 32, So 2/5 times 32 is 64/5. That doesn't reduce. And then I have to find f of 5. And f of 5 is just going to be that 64/5 times 2/5. Thank you, Julia. So when I do that, I get 2 times 64, which is 128 over 25. And because we're talking about height, I'm going to go ahead and reduce that. So it's about 5.12 feet. So if you think about that in context of the problem, he's eventually going to hit the ground, right? His bounce is getting longer, shorter and shorter and shorter. So 5.12 feet, his head is not that far off the ground. I would actually be terrified. All right, and that's our solution. Ooh, that's a thick box. All right, so again, how are the terms in a geometric sequence related? Hopefully you have enough information.